This video is a solution to question 1 on arithmetic and geometric progressions. Now this is a question I've had asked quite a few times. How do I go about solving this one? The sum of the first 20 terms of an AP is 610. So let's just go through and pass this and find out what we want. Oh, firstly, the answer A may equal to 2, but you'll find that the actual answer, the first term of the geometric series, is 32, not 2. So this answer isn't quite right. The sum of the first 20 terms of an arithmetic series is 610. The first, third, and 11th term of the series are also the third, second, and first terms of a geometric series. Find the first term of the geometric series. So let's deal with this first. We've got this series, U1, U2, U3, and this is an AP. And we know that the sum of the first 20 terms of this AP is equal to 610. But we also know that that's going to be, and if you remember the general formula, it's n over 2, 2a, where a is the first term, plus n minus 1 d. Well, in particular, what is this going to be? This can substitute in n equals to 20 into this equation, and you get 61. So 20 divided by 2 is 10, and then divide both sides by 10. You get 61 is equal to 2a plus 19d. Right? And then what about the second part? The second part tells us that the first, third, and 11th term of the series are also the third, second, and first term of a GP. So that is, if I have U11 and I multiply it by some common ratio R, I'm going to get U3. And if I multiply that by some common ratio R, I would get U1. So this was what it means when it says the first, third, and 11th term of this this AP also form the third, second, and first term of a GP. So in particular, what does this mean? We know the important thing about a GP is it's got a common ratio. So there's a couple of formulas we can use. You can use that U1 over U3 has to be U3 over U11. That's the common ratio formula. Or you can also use the geometric mean idea, where U3 squared is equal to U1 times U11. And that's the one we'll use here. But let's just quickly recall, what is U3? Well, U3, I'll start with U1, which is A, right? U1's just going to be A. And then I have to add 2 times my common difference. That will give me the third term, right? So U3 squared is A plus 2D all squared, times U1, which is my first term, which is A, times U11, which will be A plus 10D. If you're a little bit unsure about how I'm getting these, please recall we have this formula that UN is equal to A plus n minus 1d. Right, so this is the general form for a term UN. So just substitute in the correct n and you'll get these answers. These. So what does that give us? That gives us that a squared plus 4ad plus 4d squared is equal to a squared plus what? A squared plus 10ad. Good, a squareds are going to cancel off. What am I left with? I'm left with 4d squared minus 6ad is equal to 0. And so I can factorize out 2d here, and I get 2d take 3a is equal to 0. So I'm going to be able to use this equation. Let's call this equation 2. And this one, let's call this equation, let's not call this equation 1 yet. Let's rearrange this so that a is equal to 61 take 19d all over 2. Let's call this equation 1. We're going to sub 1 into 2. And what am I going to get? I'm going to get 2d still on the outside. And I get another 2d minus 3. 61 take 19d over 2. That equals to 0. So again, let's rearrange this. I'm going to get 4d squared, take 3d61 take 19 d equals to 0. So expand out this bracket, so get 4d squared minus 3 times 61 is 183d plus 57d squared equals to 0. So we get 61d squared take 183d equals to 0. Excuse me, 61d, d minus 3 equals to 0. So from this I can safely conclude one of two things. Either d equals to 0, I'm going to reject this, or d equals to 3. Why am I rejecting d equals to 0? Because an AP with a common difference of 0 is a pretty boring AP. It's trivial, so we don't want to consider that. So d is equal to 3. So we substitute d equals 3 back into, d equals 3 into equation 1. And that tells us that a is going to be 61 minus 19 times 3 all over 2. And that means that a is going to be equal to 2. So the first term of our AP is 2, and our common difference for this AP is 3. But that's not what they ask. They want the first term of the GP. So what's the first term of the GP? Well, the first term of GP is U11, right? That's what they told us. And that's precisely equal to A plus 10D. So that's going to be 2 plus 30. It's going to be 32. So that's the answer to the first part. What about the second part? Find the sum, the first n terms of this geometric series, and find the sum to infinity of this series. So what is this series? It's 32. Well, it starts with 32. What is our GP? Recall that we were told it was going to be U11, U3, U1. So what was U11? U11 was 32. Then what's U3? U3 is going to be 2 plus 2 times 3, so it's going to be 8. What was U1? U1 was 2. So what's our common ratio? Our common ratio is multiplying by a quarter each time. So the sum of the first n terms will be what? Well, we know this for a GP, that for a GP the sum of the first n terms is a 1 minus r to the n over 1 minus r. So what does that give us? It gives us that it's going to be 32. So remember, this a is actually not the same a as our AP. It's now the first term of the GP, so 32. 1 minus a quarter to the power of n over 3 quarters, so 1 minus a quarter. And do they ask to show that it is something? No, they just want us to find the sum of the first n terms. So what does that give us? Well, 32 divided by 3 quarters is going to give us 128 over 3, and then we get on the inside 1 minus 1 over 4 to the power of n, which is, I think, exactly what the answer gives us here. Yep. So that's good. Find the sum to infinity of the series. Well, S infinity, there's two ways you can do this. You can know S infinity is just going to be a over 1 take r, in which case it's going to be 32 over 1 take 1 over 4 is going to be 128 over 3. That's one way. The other way is that S infinity is nothing more than the limit as n goes towards infinity of Sn, right? So basically you take your Sn formula here and you substitute in a very, very big number for n, right? And that will give you something very, very close to S infinity, something arbitrarily close to S infinity. So what is the limit as n goes to infinity of 128 over 3, 1 take 1 over 4 to the power of n? Well, this is just going to be this is going to be what? Well, it's the limit of, it's 128 over 3 times the limit as n goes to infinity of 1 minus 1 over 4 to the n, which is 1 to 8 over 3. And if we substitute in the limit here, limit of 1 is 1, limit of 4 to the n is infinity, so 1 over 4 to the n is 0, so this is 1 minus 0, and that means 128 over 3 is the sum to infinity. And we are done.